Hi everyone, I welcome you to the presentation of this video on compound gear trains. So, compound gear trains are basically gears which have more than one gear on a shaft, as shown there. So as you can see here, we've got some gears there, which are these. As you can see on this one, there is a shaft there. Attached to this shaft are two gears, this gear and that gear. For this one, the same thing, you've got that shaft, you've got three gears there attached there, though these are simple gears. So if you have a shaft and then you have more than a gear on a shaft, such a gear is called a compound gear. Okay, so we're going to discuss this and how to do the calculation. Okay, so this is a compound gear train. I want you to understand two formulas. There's a formula for speed ratio. So speed ratio is basically a fraction of, or a ratio of speed of the first driver divided by speed of the last driver or the follower. Speed of the first driver over speed of the last driven or the follower. This should be equal to the product of the number of teeth for the drivens divided by a product of the number of teeth for the drivers. So for example, if you look at this arrangement, you have on this shaft you've got this gear. This gear is a driver. Why is it a driver? Because it's driving that gear. So that one there is a driver. So when you have a train like that, you're supposed to be identifying drivers and drivens. So if you look at that one is a two-way. It's a driver as well as a driven. It is a driven because it's been driven by that driver, and it's a driver because it is driving that shaft, meaning it's driving that gear. Then if you look at that one there, this one is a driven, which is being driven by the driver, which is this one. So this is the driver which is driving this guy. This is the driven, at the same time it's driver, it is driving that gear. And then on that shaft there is this gear which is the driver, which is driving that one there, which is the driven. So you need to know the speed ratio, which is that one, as well as the train ratio. The train ratio is basically the inverse of this one. So for the train ratio is basically the speed of the last follower or the driven divided by the speed of the first drive. This should be equal to the product of the number of teeth on the drivers divided by product of the number of teeth on the driven. Let's look at an example. So the gearing of a machine 2 is shown below. The motor shaft is connected to a gear A and rotates at 975 rpm, revs per minute. The gear wheels B, C, D, E are fixed to parallel shafts rotating together. The final gear F is fixed on the output shaft. What is the speed of gear F? So there are these gears. So you've got gear A, gear B, gear C, gear D, gear E, as well as gear F. So they've given us the speed of the first gear, which is gear A. So this gear A is rotating at 975 rpm. They want us to calculate the speed of this, the driven gear, which is F. At the same time, they've given us the number of teeth for these gears. So you're supposed to visualize this in 3D for you to have a better understanding. But if you can't, it's fine. Just need to identify which ones are drivers. So as you can see, this A is a drive. It is driving a compound gear, which is this one. On this shaft, there are two gears here. There is gear B and gear C. So this A is driving B. So this one is going in this direction. This shaft automatically will go in the opposite direction. As this shaft is driving, between those two, only one is a driver there at that side. So you look at C. C is driving this one, which is D. So D and E, they are sitting on the same shaft. They will rotate that direction. And then between them, only E is a driver to F. So if you're able to identify which ones are drivers and which ones are drivens, it will be very easy to solve this one. So let's look at the solution on the next page. Okay, so the question was this one. For easier understanding, if you can view it in 3D, it will look something like that. So you have gear A, which is rotating in a clockwise direction. This gear is rotating a shaft or a compound gear having two gears, gear B and gear C. So these will go in the counterclockwise direction like that. So that's gear B and that's gear C. These two gears, C becomes a driver because it's the one which is driving D. So you have gear D there, which should rotate in that direction, but D and E are coupled to the same shaft. They are together there, so these will rotate in the same direction as they are rotating. So this one is a driver, this is the driven. On that shaft, E is now a driver, which is driving F, and F is rotating in the anti-clockwise direction. So we have that. So this which you're seeing there in 2D, in 3D is basically that. So for us to calculate the speed of F, this will basically be, the speed ratio is basically the speed of the first driver over speed of the last driven or the follower, which should be equal to the product of the number of teeth on the drivens over product of the number of teeth on the drivers, which is that one. So NA is the speed of the first driver. So the first driver is this one. So its speed, we are denoting it as NA. And then speed of the last driven or the follower. So the last follower is F, which is this one there. And then you do product of the number of teeth on the drivens. So you need to identify the drivens. So this is the driver automatically, B is the driven, D is the driven, and F is the driven. So those are the ones we have. So teeth for B, teeth for D, and teeth for F, divided by product for the number of teeth on the drivers. So for the drivers, we have A is a driver, C is a driver, and E is a driver. Those are the ones. So teeth for A, teeth for C, and teeth for E. These values, we have them, they are in here, number of teeth for those. So if you do your substitutions there, you're going to have that. Speed for A is 975 RPM. The teeth for B, D, and F, they are those. You're just getting them from there. And then the teeth for A, C, and E, they are these, which are just coming from here. And you make NF the subject there, which is the speed for gear F. You're going to have 52 revolutions per minute. So gear F will rotate at a speed of 52 revs per minute. Thanks for watching.